All right, let's look at this here. So we're looking at ln x to the power of ln x. So we're going to have y equals the natural log of x to the power of ln x. That's going to be what we're working with here. So a little side quest here. We recognize that this form, because these are inverse functions, when you have these two functions stacked together, you get the argument back. So these are equivalent. And using our power rule, we could write this like this. That meant if we were to take the derivative, that was equivalent of taking the derivative of an exponential. And a derivative of the exponential is you get yourself back times the derivative of the argument, and this is a product rule, so you get the derivative of the first times the second plus the derivative of the second times the first, which is 1 over x times x, which is 1. This was equivalent to what we started with. And so we get this format, often written like that. And so this is the similar pattern we're seeing here. So we will write y as e to the ln of ln x to the ln x. Now if we use our power rule, we get e ln x times the ln of ln x. Now to take the derivative, we take the derivative of e, we get itself back. Times the derivative of the argument, which is ln x times the natural log of x. This is a product rule. So we get the derivative of the first times the second plus the derivative of the second times the first. So we're going to have ln x times, well, what's the derivative of this? It's going to be 1 over ln x plus the chain rule times 1 over x. Right? Because the derivative of the natural log is 1 over the argument, and the chain rule gives me a 1 over x. So we get this times this, but this is what we started with. So that's the ln of x to the power of ln of x times the ln of x over x plus 1 over x. Or the ln of x to the power of ln of x times ln of the ln of x plus 1 all over x. So the key here is this pattern in form of if I have something to itself, we can write it like this. This lets us exploit e being its own derivative. We then have to watch our product and chain rules, because we'll get e with its own derivative times the derivative of the argument. And so in this case, this whole thing's, the argument gets this extra ln part here. And in a lot of these cases, the power rule with logarithms will help us pull some function out front.